Hello and welcome to this particular video. My name is Will, and in this video I want to walk through how you can set out to create a pseudo 3D effect using Win2D and C# in a 2D environment. So without much further ado, I'm just going to demonstrate this right now. So I'm just going to move across my scene. And if you pay a little bit of attention to the ground graphic, the kind of checkerboard graphic, you'll notice that it's sort of skewing about some kind of axis apparently, and it kind of gives the appearance of a pseudo 3D, especially with a parallaxing background. So I'm just going to go back a little bit, especially on this left hand side. That it kind of looks, I can kind of see that effect a little bit more when I'm about here. But I'm just experimenting with this at the moment. There's a lot you can do. This is a very naive and a simple approach, but nonetheless, I'm going to show you guys how to get started with this in case you're interested in implementing some kind of pseudo 3D, some sort of almost like a mode 7 style skew transform on your graphics. So without much further ado, let's just get straight into the code. I'm going to go ahead and minimize this. Actually, it'll be better if I just stop the program so that we can get rid of the diagnostic session. So I'm not going to run through the entirety of the engine framework, but what I will do is draw attention to the canvas animated draw function, which is actually where I am now. Is the animated draw. I said canvas animated draw. It's actually animated draw. And if you watch any of my Win2D videos, you should be aware of what this is. It's basically, it's the function that is called as part of the draw loop. And what this allows me to do is to place all my draw logic within this function, and it runs at a speed of 60 frames per second. So in here, I went and created a local function called draw backgrounds. And what you got to do is you need to create a transform effect. So a transform effect 3D, or sorry, a transform 3D effect. You want to construct this class. And what I did, I set a few parameters. I'm not sure if I don't know what the output of interpolation mode is, if you can observe it. But from just this nearest neighbor, I suspect it hints towards the quality overall of the transform, because I think the nearest neighbor is an algorithm. Yeah, so what do we have here? We have like linear, we have cubic and anisotropic. I can't even pronounce that properly. Multi-sample linear, and this is just a technique for the I believe for the transform itself, because when you tend to use like image editing software and you want to resize, you can choose, especially, well, I suppose with certain image editing software, not all of them, like Paint.net, maybe Photoshop as well, you can choose the algorithm that you want to use, and they all have different properties in terms of the output. Like I know nearest neighbor is kind of, it's lossy, but the advantage is that it's quite fast, I think. So it's rather efficient, economic. But then you might have a different mode, which I'm not too sure off the top of my head what it's called. I think there's like super sampling, but I don't know what the ratio is from economic and quality. But I just went ahead and went for nearest neighbor. But you know what? Let's just change this and just observe the effect. It even says on the description. Don't know why I'm not just reading that. So this option is the fastest but outputs the lowest quality image. So it's a sample algorithm. Linear. This option is slower but outputs a high quality image. And that's the thing. If I'm creating an engine that I want to deliver fast graphics that targets a frame rate of 60 frames per second, I would be more inclined towards the economic route. So I did go for nearest neighbor, which was the lossiest, but it's the fastest. So I think that's a decent shot. I'm gonna leave it there. Whoops. Just go back. And I'll just put my semicolon. And now here's the thing. So you also want a matrix 4 by 4. You want to construct a matrix 4 by 4. I put mine in global scope, and that should be a comma, I think. Yeah, I think that should be a comma. Yeah, that's fine. And when you construct this matrix 4 by 4, I went ahead and created it from your pitch row. What you can do, you're basically configuring your matrix, and there's different ways you can configure your matrix. So for example, pertaining to how you want to transform your image. You can create from quaternion, I cannot say that properly. Create from axis angle, and the overloads you just supply a vector 3 and a float for axis and angle respectively. But with your pitch and roll, I found it quite easy to understand because if you know how, if you have an object that you're manipulating with your pitch and roll, it's somewhat, for me at least, it's easier to visualize the effect. And then it just meant that when I was tweaking these values, they're globals and they change depending on the input of the analog stick, then it just gave me a little bit more of an idea as to how the plane is going to shift. So it did kind of help. So, and what I do after that is that I'm just drawing the output image. So if I just go ahead and highlight transform effect, you can see down here, I'm calling e.drawing session.draw image, and I'm passing the transform effect. And what else am I passing there? The X and Y position, which are also globals, transform effect X and transform effect Y. So what I did is that if I just scroll down, I have an inputs how can I say, like a command buffer input check sort of thing. So any input of the controller, potentially I can read off that and then do some form of action depending on what I do. So I'm just trying to find the functionality here where I actually create the parallax. It should be up here somewhere. So let me just quickly check. Here we go. So where are we? As you can see, my global yaw is here, and I'm post incrementing it by a very experimental amount. So if you're familiar with yaw pitch and roll, you'll know how that affects a 2D or rather 3D geometry, or 2D in this case. So I won't really go into the technicalities too much. So I'm doing that here. So for every time that I am in a state of running to the left, as you can see, I've just encapsulated the functionality of commanding the player character going to the left through this enumerated list. No, sorry about that. I'm actually quite wrong there. So what I'm doing a check of the controller directly. So if the left thumbstick is basically pointing to the left, or if the D-pad is D-pad left, as you can see here. And it also does a further check if I'm holding down as well, just for leeway if I was crouching. So anyway, then I'll actually invoke the crouch back. I will assign state to crouch back. Otherwise, so if I'm trying to go left, I change the state to run left, and also I scale the background. So that's what I'm doing here. Sorry about that if I was a little bit confusing there. So I'm post incrementing, or rather I'm post decrementing yaw by this particular amount, as you can see on the screen. And I'm also parallaxing the background rect, which holds the background. So that's very, I would say, I would admit, quite a rough demonstration. It's very brief. I didn't go into too much technicalities, and a lot of this stuff is quite experimental. But if you do follow the Win2D documentation, the official GitHub documentation, it does go into a little bit more detail as to some of the other effects. Pretty much all the effects you can do in terms of transform and scaling for Win2D graphics. And so I highly encourage you to check it out if you are interested in that sort of thing. So thanks very much for watching, guys. I just wanted to share this demonstration with you all, and I hope you have a great day. Take care. Bye-bye.